Hi students, today we discuss about Fresnel's diffraction. At first we know about the diffraction. What is diffraction? The diffraction is when light from a narrow linear slit is incident on the sharp edge of an obstacle. This is an obstacle and sharp edge. So a light comes from the source and which incident on sharp edge obstacle. Now it will be found that their illumination to some extent within the geometrical shadow of the obstacle. Geometrical shadow actually this part, and the actually illuminations mean there the bright fringe and dark fringe. Now the light will bend actually the source which emits the light or rays and incident on the obstacle, and then the light or ray actually bend through the edge, actually sharp edge, and we see the within the geometrical shadow where some illumination means actually the bright fringe or dark fringe. So this phenomena is called the diffraction of light. So what is diffraction of light? Light or source or ray comes from source and incident on a well-shaped obstacle, and then bent by the obstacle, and we see the some illuminations means bright fringe or dark fringes within the geometrical shadow. So this phenomenon is called the diffraction of light. Now difference between interference and diffraction. Interference, actually what is interference? Two coherent sources which emits rays and superpose and produce bright fringes and dark fringes. So these are the two coherent source which emits rays or light, so which are emits also wavefront. So wavefront are superposed, and there we see the interference. But diffraction actually different parts of a wavefront. Actually this means one source which emits lights, and the wavefront of this source of this light, these wavefronts actually divides in two parts, and they now divides two parts, and they, if by superposing these two wavefronts, actually diffraction produce. So in this case we see the diffraction, and in this case we see the interference. Actually diffraction is produced by superposition of secondary waves coming from the different parts of the same wavefront. So diffraction is the phenomenon of superposing the secondary waves coming from one wavefront of the same wavefront. Okay? And interference is the actually wavefront coming from two coherent sources, coherent sources which are superposed, and then they produce actually the interference phenomenon. So this is the difference between interference and diffraction. Now types, actually or classes. classes. So there are two class of diffraction. First, Fraunhofer diffraction, and second is Fraunhofer diffraction. And second is Fresnel diffraction. Fraunhofer diffraction. What is Fraunhofer diffraction? Actually, Fraunhofer diffraction is one type of diffraction in which the source and the screen, the distance between source and the screen is infinite, and Fresnel's diffraction. In Fresnel's diffraction, this distance is finite. Actually, the distance is small, and in Fraunhofer diffraction, the source and the screen, the distance between these two source and the screen actually infinite, and the distance in the Fresnel's diffraction, actually the distance between source and screen is finite, small distance, and the wavefront, as they comes from, actually the wavefront comes from infinite distance, infinite length. So actually the wavefront in this class, actually wavefront actually plane wavefront, and in this category actually wavefront spherical wavefront, and second cylindrical. So the wavefront in the case of Fraunhofer diffractions actually is plane wavefront, and in the Fresnel's diffraction this wavefront actually spherical or cylindrical. So these are the difference between two classes of diffraction. Actually, Fraunhofer diffraction means the distance between source and screen is very long distance, and the distance between the source and screen in the Fresnel's diffraction case is very small, and so in the case of Fraunhofer diffraction, the source and the screen, actually we use two convex lens to focus the rays. Two convex lens actually we used, and then we see the diffraction pattern. And in the case of Fresnel's diffraction, there we do not use actually the convex lenses. There is no need of actually using the lenses. So these are the difference between the Fraunhofer diffraction and Fresnel's diffraction. And in the next video I discuss about the Fresnel's diffraction in details. And so thank you for watching this video.